Good day everyone and welcome back to the channel. In today's video we're going to derive the electric displacement in terms of Gauss's law within a dielectric medium. Now in physics, the electric displacement field is denoted by the letter D, with epsilon naught being the permittivity of free space, E the electric field, and P the polarization density. Now it's a vector that appears within Maxwell's equation. So without further ado, let's go ahead and get started. Now what we're going to do is start with this equation. Here, rho is the total charge density within the dielectric, and rho is actually going to be expanded out to show it's going to be the free charge plus the bound charge, where the bound charge rho sub B equals negative del dot the polarization density. Now what this term does is that it produces the accumulations of bound charges within the dielectric. So we're going to take this information and we're going to add it to the equation we started with, expanding everything out. And I'm kind of writing everything out step by step, just so you can follow along. Now, something to note is that this form of Gauss's law is defined by the free charges within the dielectric, so we're going to do some simple algebra to get rho sub F by itself. Now what we're going to do here next is we're going to actually factor out the del operator. Now the free charge is also defined by del dot the electric displacement. And if we look at what's within our parentheses, we'll see that this relation is also what we started with here at the top. So this is what the, I guess the electric displacement, which is the vector, this is what the equation is here. So when we plug that back in, we see that it checks out, it's equal on both sides, so that's how we know that we derived it correctly. And that's it, just a short, quick derivation. If this video was helpful, go ahead and give it a like. Let me know what you think in the comments below. Would you like a more detailed explanation, or would you just like a straight to the point derivations, something that doesn't take very long and with as little explanation as possible? As always, I hope you have an awesome day. Take care.